In the lesson number of factors, we learned how to find the number of factors of any given number. In these lessons, we are going to build on that logic and try out a lot more tougher questions. We'll begin with the placement of factors. By placement, I mean when we arrange the factors in increasing order, ascending order. So let's start with the same number that we had earlier. So we had 24 and the factors I'm looking. So factors are always less than the number. I like to look at it that way. So I'll start writing on the left hand side. The factors are numbers which divide them. 1, 2, 3 will divide, 4 will divide, 5 does not divide, 6 divides, 7, 8, 9, 10, 11, 12. And once we reach the half of it, I had said earlier, the next one will be the number itself, right? We are going to look at that also. So this is my number. Let's do our check. 24 in a factorized form is 8 threes are, that is 2 cubed into 3, right? And the number of factors we have found is going to be 4 into, the index of 3 is 1, so into 2, that is 8. Have we the 8 factors? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So there's no error out here. Now what is it that we mean by placement? Observations. A lot of these are just the questions that we're going to do are going to be based on observations. So if you notice, we see the smallest and the largest, the first and the last factor, when we multiply, it results into 24. The second and the second last, when we multiply 2 into 12, it also results in 24. And it's worthwhile to say 24 is a number out over here. The third and the third last, 3 into 8 also becomes 24. And 4 into 6 is also 24. Right? And look at this image. This image is very interesting, right? The first, last, second, second, last, and so on. When we have such sort of pairing, you could obviously speak in terms of first, last, second, second, last, third, third, last, fourth, fourth, last, right? But then we don't usually use the terms fourth, fourth, last, and all. So such an image, the best way of explaining it is, this is going to be the middle. When all the factors are written in ascending order, the factor occupying the middle position. Remember, we are just talking, or rather, let me write it also. Remember, when we say middle, we are basically meaning not the average of it. We are meaning the middle position, right? And what I was saying is, this is best spoken in terms of product of factors equidistant from the middle. So the two factors, they are most closest to the middle, the product of them. The next two factors, which are at a position of 1 to the left of middle, 1 to the right of middle. So positions, what was it, equispaced from the middle would multiply to 24. So I've got the middle into picture. Let's think with terms of theory. Does that mean factors, if one is a factor, there is another factor with which it will multiply to become the number. For example, what I'm saying is, if 2 is a factor of 24, that means that the quotient is a natural number, 12, and the 2 and 12 can obviously interchange positions. Right? So what it basically means, a number will be a factor only when it is multiplied with another natural number to result in the given number. Right? So does it mean that factors are going to exist in pairs? So that is what this picture is trying to suggest us. 1 and 24, 2 and 12, 3 and 8, and so on, right? 4 and 6. So does it exist in pairs? Oh, and if they exist in pairs, then it means that the number of factors are even. Number of factors will be even. Is it so? Can there not be odd number of factors? Let's have a look. Let's take another number. 36. So n now is 36. Let's write the factors first. So factors of 36, 1 will divide, 2, 3, 4, 5 doesn't, 6 will divide, 7, 8 doesn't, 9, yes, 9, yes. If you notice, 9 fours are 36. Since you have learned something, we can progress a little faster. This is 3. 3 into something. So let's see, 9. 10 wouldn't, 11 wouldn't, 12 would. And do you see a 12 into 3? So let me draw that. 9 into 4 was that. So obviously 3 into 12 is 36. Okay, let's continue first and then check. 12, 13 doesn't, 14 wouldn't, 15, no, 16, no, 17, no, 18. And do you still see that path? And have you reached half of 36? And therefore I said that the next factor is going to be just 36. Let's not race ahead. Let's confirm it. 36 can be factorized as 4 into 9, that is 2 square into 3 square, and the number of factors is 3 into 3, that is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have not missed anything, right? But then we were just talking about how factors exist in pairs. If they exist in pair, then how did we get an odd number of factors? This is an even number of factors, right? This is an odd number of factors. So what happened to that pairing business? Let's say, is there a pair 1 and 36? Yes. 2 and 18? Yes. 3 and 12? 4 and 9. And if I continue the process, 6 and 6 itself, 6 multiplied with 6 itself is going to become a 36, the same number again, right? So think about it. This is a specific middle. This is the middle position. But now what is the difference between what we did up and what we did here? In the middle one, there is a specific number, right? Whereas here, there were two different middles. And the so-called exact middle was appearing somewhere in between the two middles, right? Or we just say two middles. Okay. Odd number, there is a precise middle. And what relation does that middle have to a given number? That middle number into itself is going to be 36. So can I say that middle number is nothing but root 36? And root 36 is a perfect number, so it comes down in the list of factors. Let's check out over here. So n is 24. So the middle number should be a perfect root 24, and root 24 is going to, its root 25 is 5. So this is just going to be a little less than 5. I don't know, I'm just putting it randomly, 4.9 something or 4.8 something, whatever it is, closer to 4.9, right? Oh, and is 4.9 somewhere in the middle of it? Yes, right? Between 4 and 6. So watch out. I'm not saying precisely middle. Remember, they are not equidistant in terms of value. Right? From the middle, this is 3 less. This is 8, quite a large number. 1 is how much less than 5? 4. 24 is much larger. We are not talking value-wise. We are talking position-wise in that case, right? I hope you get that difference. So, number of factors could be odd, but when the number of factors is odd, there's a precise middle, one single middle value, and that middle value has to be root n. That means n has to be a perfect square. Let me just do that theoretically and finish it. But if you learned what we are talking, yes, the number of factors are going to be even when the number, when n is a non-square. Let me just write it this way, is a non-square. And if we, let me write it the other sentence, if n is a perfect square, if n is a perfect square, then the number of factors is going to be odd. And if you notice, I have interchanged the order of the sentences. Here I started with number of factors is even and deduce something about n. Here I am starting with n and deducing something of number of factors. You need not worry about the order because this is implies and implied by. So if any one of the sentences is true, the other has to be true. So if n is a non-square, it has to have even number of factors. If number of factors is odd, it has to be a perfect square, right? And this is not a very difficult task. Yeah, you can even do it by theory. For example, I'll just get you started and you can do the other ones. So I know a number of a factorized form could be written as powers of prime. So let me start with n is a square. If n is a square, what do I know? I know that A, B, C and D and all of them are even, right? Multiples of 2. And if they are even, what do I know? I know A plus 1, B plus 1, each of C plus 1 individually are odd. And hence I also know their product. Their product, all of them are odd. So if the product is also odd, and their product is odd means number of factors. Their product, which product I am talking of? A plus 1. What is the number of factors of this number? Number of factors is A plus 1 into B plus 1 into C plus 1 and so on. Right? So number of factors is going to be odd. You can easily do the reverse way also. Let me quickly do the reverse way. If I say the number of factors is odd, this implies the product A plus 1 into B plus 1 into C plus 1 is odd. And so on, sorry. When can a multiplication of individual numbers is odd? That means each one is odd, right? So the difference between the first sentence and the second one, the first one is the product, and here I am saying individually A plus 1, B plus 1, C plus 1, all of them are odd. And if all of them are odd, take away the 1, what I will be getting is each of A, B, C is even. And if each of A, B, C is even, then my conclusion is that n is a square. Right? But this is all academic interest. We are not really interested in this, right? It is just, I am just doing it to tell you that things are very basic in nature, right? Even, odd and so on, right? You can easily do the proofs and so on, right? It gives you more confidence. Sorry, the recording just stopped at that moment, but I was through with the theory. What I was talking is that such academic workings or proofs or so on add to your confidence, but the application oriented will only be based upon the observations that you have gathered, right? So I hope you have built on your own observations. I'm going to next do questions on these observations.